In this section, we will discuss Linux file system permissions. In order to understand access to files and directories, we need to review the owner and group membership of our individual users. The ID command can show us what our user ID is, as well as our primary group, and any supplementary or auxiliary groups that we're a member of. In my case, I am the user student. My primary group is my user private group, student, and I'm also a member of the group wheel. When I look at permissions, I use the ls-l command. By default, this will show the contents of my current directory. With this output, you see two names in the middle. The first name is the owner of each file or object, and the second field is the group that's associated with that file or directory. I'm in my home directory, so most of the files and directories are owned by myself, student, and my private group, student. A few files here have been created which have other ownership, such as root, or other group affiliation, such as wheel or root. While a user may be a member of multiple groups, a file is only associated with a single group. As I begin to look at permissions, I move to the first field of this output. There are 10 bits at the very beginning of each line. The first bit is the type of file that we have. There are 7 types within the Linux file system. The most common ones that you will see are D for directory and dash for an ordinary file. An ordinary file could be a text file, a Word document, a PDF or graphics. It could also be an executable, either a binary or a script. After the type, the next 3 bits are associated with the permissions for the owner of the file. In the first example here, the file is a directory called desktop. It's owned by the user student, so as the user student, I will use these permissions to determine my access. Here I have R, W, and X, or read, write, and execute. If I was not the owner, the next thing I would evaluate is whether or not I'm a member of the group. If I'm not the owner, but I am a member of the group, in this case student, I would look at the next 3 bits in the permissions. This indicates the access for the group members. Here it is an R for read, a dash indicating that the write permission is not enabled, and the X for execute. If I'm not the owner and I'm not a member of the group, then I fall into the other category and I look at the last 3 bits of the permission field that is represented. Here again I see read dash X, so read and execute, but not write privilege. I have a random file down here that is very similar. It's owned by student. Its type is a dash or an ordinary file. The owner has read and write but not execute. The group, in this case student, has read and write but not execute. And others have read access only, no write and no execute privilege. Let's look at what read, write, and execute mean with files. The read file, or read-only file in my case, is readable but not writable. For read privilege, I can view the contents, such as with the cat command. There happens to be no content here. I might use the less command. I might even use a nano command and bring this into an editor, where it will tell me at the top that this file is read-only. It will also give me a warning at the bottom that there is no write permission. I could still insert content, and then I could do a save as in order to create a new file. If I have write privilege, such as on the read-write location, I'd be able to add content to it. So if I cat read-write, I see that there is some information. If I try and edit the read-write file, I see the file name at the top, I see information at the bottom that this is readable, and I can add content, and I can actually write out and save this information and exit. I could also simply append text, such as echoing new content and appending it to this particular file. Again, I can go back and cat the file to view it. Looking at another example of read privilege, here's root file 1. Only the owner root has read privilege, so if I try to view the contents of this file, I get permission denied. Similarly, if I try to echo content to root file 1, I get permission denied. On the other hand, I do have privilege to view root file 2 and even to add content and append it to root file 2. Looking again at the permissions for root file 1 and 2, root file 1 is readable only by the owner with no privilege for the group wheel. I am a member of the group wheel. With root file 2, I'm not the owner, I'm not a member of the group root, but I'm other, and other has read-write, so is able to modify the contents of root file 2 by appending content to it. Finally, let's look at the execute permission on files. If we have a binary or a script and we want to run it as a command, it needs to have execute permission. If we look in the current directory at the myls2 and myls3 commands, these are copies of the ls command. myls2 is not executable, so I can run the basic ls command, but if I try to run home student myls2, I get a permission denied. It's readable, it's writable even by the owner, but it's not executable by anyone. On the other hand, if I try to run myls3, that will actually work. The color's a little different from the original ls command, but the output text-wise is the same. This file has the execute bit, and so therefore I'm able to run it as a command. You should note that execute is not automatically given to new files. It can be preserved through a copy command or as extracting from an archive, and it can be changed by a user who has downloaded a file or by an application that has created or downloaded a file. But by default on creation, ordinary files will not have execute permissions. If you want to run that file as a command, you would need to change the permissions and add the execute bit. Now let's look at directories. We'll start with the /home directory. The bottom two directories, student and visitor, are directories that were created when these users were created. Note that they are only accessible by that particular user. Only student can access student's content, and only visitor can access visitor's home directory. If I do an ls home/student, I'm able to see that content. If I do an ls of home/visitor, I get permission denied. This is the default from Red Hat Enterprise Linux, that our home directories for our users are private to only those users. If we want to share content, we would need to change those permissions or add a separate shared directory someplace. That's what's been done here. The root user has created /home/shared and expanded the permissions and group affiliation to allow additional access. If I do an ls-l of home shared, the default of ls-l is to view the contents of that particular directory. If I add the D option to this, I see information about the directory itself. In this case, the ownership root, the group wheel, and the permissions at the very beginning. Recall that I am the user student. From ID, I can see that I am a member of the group wheel. Evaluating these permissions, I'm not the owner, but I am a member of the group, so I'll use the group permissions, and I have read, write, and execute for this directory. In order to view the contents or do an ls of this particular directory, I need to have read access. In order to cd into the directory, I need to have the execute permission. And in order to create a new file, I need to have the write privilege for it. So on a directory, we need read access to view the contents of that directory, such as with an ls command. We need execute permission in order to change into that directory or otherwise access the directory. And we need write privilege on the directory in order to create files within the directory. We also need that write privilege in order to delete files in the directory. So if I look, once I'm in this directory, I have the new file that I created, and because I did create it and have write privilege on the directory, I'm able to also remove that file with rm. I can also create new files with copy commands. I can copy readme to readme.old. And that ability to create that destination file is based off of having write permission within the particular directory where I need to create the file. If I was to move a file, I would need write access in the destination to create the new file, and I would also need the write privilege on the source directory in order to remove the old entry. Another interesting feature about the write privilege on a directory is that that is the only permission I need in order to delete files in that directory. For example, look a little bit closer here at root file 3. It's owned by root, group of root, and is read-only by others. So I can view the contents of root file 3. But if I try to modify root file 3, I get permission denied. I can't change the contents of the file. However, I do have write privilege on the directory. Therefore, I have the ability to create and remove any file in this directory, including root file 3. RM does give me a warning that it's a write protected file, but when I say yes, I want to remove it, it will go away. This is true in a user's home directory as well. If I return to my home directory and I look a little closer there, we have root file 1 and root file 2. Remember that I could not even read root file 1. That was permission denied. But I'm in my home directory where I have write privilege, so I can remove root file 1 even though I cannot even read it. All that is important for me to be able to remove a file is that I have write privilege on the directory. Write privilege is about modifying the object. If that object is a text file, we can append text or bring that file and make changes in an editor such as Nano. If that object is a directory, then we're modifying the contents of the directory by adding and removing files. Looking at the commands that we've done, we have seen that ID has helped us to determine what group membership we have or someone else has. ls-l will show us the ownership, group, and permissions of individual files. ls-ld will help us view the information about a directory itself. In order to create a file, we need write privilege on a directory. That write privilege also allows us to remove files within that directory. If we have read access on a directory, we can view the content, such as with ls. We need execute permission in order to cd or change into a directory. For an individual file, read access allows us to view the content, write access allows us to modify the content, and execute allows us to run that file as a command from the command line.